everyone. Today I would like to talk about polar coordinates, velocity and acceleration in polar coordinates, and of course the relation between Cartesian coordinates and polar coordinates. So we begin with some coordinates here. I think this is x and this is y. This is x and this is y. So we have the point P here and this vector here, which is r vector. So this is x component and this is y component. So the r vector can be written in I, unit vector in x direction. So this is I, and this is j. So we have ix plus jy, and we have to find the relation between polar coordinates. So the polar coordinates are something like this. For example, we have r, and this is r, and this is theta. So you have so this is polar coordinates. It looks like this, but how we can find the relation? So we have here x, y, point B, this is r vector, and this is x, this is y, this is theta. So the sine of theta is y over r, and the cosine of theta is x over r. From those two we can find that x is r cosine theta and y is r sine theta. For example, if we have x2 and r2, we can find the component, the angle theta. Of course, we have some relation that, for example, r squared is x squared plus y squared, and tangent of theta is y over x. For example, if you want to find the angle, we have y, we have x, we divide those two and we can find the angle theta and the relationship between those two. But in order to find the velocity, I'm going to use a different method. So I'm going, this is x, this is y, this is point P, for example, this is r. But now I'm going to introduce the new coordinates here. This is a theta and this is ar. So this is the unit vector in r direction, and this is the unit vector in angle direction. This is the angle theta, and we have, so we can zoom this one, only this one. We have here AR A theta, or like this. And we are going to move little bit. We are going to change those two little bit. So ER is moving this piece for this distance, which is delta AR, and E theta is moving for this separation here, which is delta E theta. And the position vector R, so the R vector is R component times, R vector is R component times ER, the unit vector in this direction. So in order to find the R, we have to take the time derivative. So the time derivative is V, which is equal to dr by dt, which is equal to d by dt of this one, which is R times ER. Now we have to use some rules, product rules for the derivative. So this is dr dt times ER plus R der dt. This one is R dot, the first derivative, in ER direction, plus R times der by dt. But we have to find this one. What is this one? So that one is like this. We can find the delta ER is approximately equal to E theta delta theta. And when we take the time derivative, der by dt, this is E theta d theta dt, which is theta dot, the first derivative of time, in E theta direction. And this one is equal to this one. So the velocity in polar coordinates is r dot er plus r times theta dot in E theta direction. This is the velocity in polar coordinates. So from this relation, we can find the acceleration in polar coordinates. So we take the time derivative of velocity. So the velocity was v is equal to r dot er plus r theta dot E theta in theta direction. So this relation, I'm going to repeat this relation. This relation comes from this picture here, from this picture here. So the acceleration A is equal to dv by dt of r dot er plus d by dt of r theta dot E theta. And this is equal to r double dot er plus r dot der by dt plus, so this one is like this, d by dt of r theta dot times e theta plus r theta dot de theta by dt. I'm going to write that delta e theta is equal to minus er delta theta. This is equal to r double dot er plus r dot, so der divided by dt dt was theta dot e theta, so this is theta dot e theta plus the product rule of those two, so this is r dot theta dot e theta plus r theta double dot e theta plus r times theta dot de theta by dt is this one is minus er d theta by dt, or which is equal to minus er theta dot. This comes from this relationship. So this is minus theta dot er. So now we are ready for components. So this here, so we can write r double dot minus r theta dot squared in er component and we have so yes, here is minus, and we have plus 2 r dot theta dot, this is 2 r dot theta dot plus r theta double dot in a theta component. So this is the acceleration in polar coordinates. I'm going to put this one in box. In next video I'm going to show you the velocity and acceleration in spherical coordinates, which is little bit not hard, but it takes longer. So thank you very much. See you in next video.